Hey guys, today we're going to learn how to graph linear inequalities. So if we look at the screen, the graph that we have right here, if you notice we have a line that's graphed right here on the coordinate plane, and if we look at this line, you notice it's a solid line. Okay, that's going to be important because in a little bit we're going to have some of our lines be solid and some are going to be dashed. The other important piece I want you to notice is the shading. So if you notice right now, this is underneath the line here is all shaded. That means we have an infinite number of solutions to this inequality, and every area in that shaded region, including the points that are on the line, actually satisfy the inequality. What I mean by satisfying the inequality, if we go to the notes, 45A, it says which ordered pair is not a solution of this inequality. We're going to take each of these ordered pairs and plug them in. So we have the linear inequality x minus 3y is less than or equal to 6. We just plug in our x and our y value. So for A, we would end up with 0 minus 3 times 0 is less than or equal to 6. Or 0 minus 0 is less than or equal to 6. 0 is less than or equal to 6. That's true. So that actually would be a solution. Okay, so that's A. If we look at B, we have the ordered pair 6, negative 1. Okay, A was 0, 0. 6, negative 1, if we plug it in, we're going to get 6 minus 3 times negative 1 is less than or equal to 6. 6 plus 3 is less than or equal to 6. We end up with 9 is less than or equal to 6. Well, that's false. So that's a false statement. So this is not a solution. Okay, so far it looks like our answer is B. All right, let's go ahead and do C and see what we come up with. So we're going to plug C in. Let me get rid of this line here. Okay, so we're going to take C and we're going to plug it in, the ordered pair 10, 3. All right, we've got our x minus 3 times 3 is less than or equal to 6. 10 minus 9 less than or equal to 6. We've got 1 is less than or equal to 6. So this is a true statement. So this is a solution. And then D, if we plug in the value negative 1, 2, we've got x, which is negative 1, minus 3 times positive 2 is less than or equal to 6. Negative 1 plus 6, okay, is less than or equal to 6. We end up with 5 is less than or equal to 6, and that one is also true. So the answer here would be B. The only ordered pair that's not a solution would be 6, negative 1. Okay, let's try a few ourselves. So if you look at the next 3 examples, I want you to try them. Okay, so pause the video, and then when you're ready, start it over again. Okay, so when you come back, you should have for this one negative 0. Doesn't make sense, but plus 2 times 0 is less than or equal to 8. We've got 0 is less than 8, which is true. So because it's true, it is a solution. Okay. 0, 4, if we plug in, we've got negative 0 plus 2 times 4 less than 8. So we've got 8 is less than 8. That's a false statement because it's not less than 8. It's less than or equal to, but it's not less than. So this would be false. So therefore, this would be a no. Okay. And then for the last one, if we plug in 3 and 5, we've got a negative 3 plus 2 times 5 is less than 8. Negative 3 plus 10 is less than 8. We've got a 7 is less than 8, and that's true. So this is a yes. It is a solution. Okay, so moving on, if we go to graph linear inequality in 2 variables, we're going to look at this inequality. Before you graph, 2 important things to recall. If an inequality is less than or greater than, then the line of the graph is dashed, okay, or dotted. All right. Dashed or dotted. Okay. If the line of the graph is less than equal to or greater than equal to, the line of the graph is solid. So this is similar to when we have one variable. Remember, if we had less than or greater than, we would have an open circle. And if we had less than equal to or greater than or equal to u, we would have a colored in circle. So it's similar, except that when we have a line, it's either going to be dashed or dotted if it's just less than or greater than. But if it is less than or equal to or greater than or equal to, we do want to make a solid line. And that means that all of the ordered pairs along that line are actually included, and they are true for the inequality if they're solid. If it's a dashed line, those values are not. So in order to graph it, what we want to do, all right, is first graph the linear inequality, make the line solid or dotted accordingly. So this graph that we're doing is y is greater than 4x minus 3. So let's write that here. Y is greater than 4x minus 3. Okay, so just to graph it, I'm already in the form very similar to, well, it's in slope-intercept form. So instead we did it with an equal sign, but we have an inequality. So our y-intercept is negative 3. 1, 2, 3. Here's our negative 3 is our y-intercept, and our slope is 4. So let's rise 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Or we could go down 4. 1, 2, 3, 4 into the left 1. Okay, 1, 2, 3, 4, and over 1. Okay, now this is important. Notice we've got greater than symbol. Because it's greater than, that means we're going to make a dashed line. Okay, so we're going to make a dashed line, and if it's not that straight, I apologize. I'm doing my best I can. Okay, so I made a dashed line. All right, and now the second part of this is to decide which way I want to shade the graph. Okay, I can pick any ordered pair. It does not matter which one. Okay, for simplicity's sake, a lot of times I like to pick the point 0, 0. And you can only pick that point if that point is not on the line. Okay, 0, 0 is not on the line. It's not letting me change it to red. Here we go. Okay, so 0, 0 is not on the line. And this point's going to help me to decide what side to shade. If I test this point and it's true, then I'm going to shade the side of the line that has 0, 0 included in it. But if I test it and it's false, then I'm going to shade the other side. So our test point is 0, 0, and again, it doesn't matter what test point you pick. You just plug in this value into the inequality. So my y, 0, is greater than 4 times my x, which is 0 minus 3. 0 is greater than negative 3. Well, is 0 greater than negative 3? Yes, it is. So that's a true statement. So that means the point where 0, 0 is, because it's true, it's going to be shaded. So I'm going to just come here and highlight it, and I want to shade. Whoops, that's not a very good shading color. Let's pick, there we go. Okay, and let's pick a bigger, okay, let's get a highlighter on. Okay, so we want to shade. We're going to shade this whole side. Okay, now had I tested that point and it was negative, and it was a false statement, then I would have shaded the other side of the line. Okay, so all of the values in the shaded region are considered solutions to the inequality. Okay, so if I move on, I've got another inequality. I need to make sure that I rearrange the problem and I put it into slope-intercept form. Okay, so in this case, we're going to subtract x from both sides. We get 2y, oops, let's pick a better color here. 2y is less than or equal to negative x plus 0, and then I divide by 2. So y is less than or equal to negative 1/2 x. Okay, so we want to graph the inequality, and then we're going to make the line dotted or solid accordingly. So y is less than or equal to negative 1/2 x. Y is less than or equal to negative 1/2 x. Okay, I just want to make sure that I wrote that down. Yep. Okay, so let's graph that. Well, first off, the y-intercept is 0. Okay, and then our slope is negative 1/2. So let's go down 1 over 2 or up 1 to the left 2. Make sure, do we have a negative slope happening? Yes, we do. Okay, all right, so because this is less than or equal to, we want to make sure we actually make a solid line. Okay, so it's going to be a solid line looking something like this. Okay. All right, now we want to test a point. We don't want to pick the point 0, 0 to test, even though 0, 0 is easy. We can't do that if it's on the line, and it is. So let's pick another point. In this case, let's pick the point 2, 2. It doesn't really matter what we pick, but our test point is 2, 2. So I plug it in. 2 is my y, is less than or equal to negative 1/2 times 2. Okay, 2 is less than or equal to negative 1. Okay. Now, is 2 less than or equal to negative 1? No, that's a false statement. Okay, now because that's a false statement, that means instead of shading the side with 2, 2, I'm actually going to go and I'm going to shade the other side. Okay, so we want to shade this side. Okay, because it was false. So we shade everything on the other side. And that tells me everything on this side of the line satisfies the inequality. Okay. So now I want to look at some special cases. So this is y is greater than or equal to negative 3. So because there's only one variable here, we're actually going to think of hoi. All right, so this is going to be our hoi. Let's get my pen working here. It's not really cooperating today. Okay, so hoi tells me that y is greater than or equal to negative 3. So it's a horizontal line. We're going to go to y is at negative 3, and we're going to make a horizontal line. But because it's greater than or equal to, it means we're going to make a solid horizontal line. Okay, now I think the special cases are actually easier. So if it's greater than or equal to negative 3, think of this y-axis as a number line, and anything greater than y is negative 3 is going to be above the line. So we're actually going to graph everything above the line like that. Okay. All right, looking at number 2. Number 2, we've got x is less than or equal to negative 1. So then we're going to think of vox here. So it's going to be a vertical line. And x is less than or equal to negative 1. So we're going to go to negative 1 on our x. And we're going to make a vertical line. And again, it's going to be solid because it's less than or equal to. Okay. And everything less than it is actually going to go to the left. So let's shade here to the left. Okay. All right, so with that, I want you guys to try for me number 3, 4. Yeah, just 3 and 4, and then when you come back, we can check them. Okay, so pause here and try it. All right, continuing on, number 3 is already in slope-intercept form, so let's graph 1, 2, 3. The y-intercept is at 3. Okay, and our slope is 1, so rise 1 and over. It's going to look like this. Okay, and it's also just greater than, so it's actually going to be a dashed line, okay, or dotted. Okay, so there's our line, and now let's test our point, okay, and in this case, let's test the point 0, 0. So if I plug in 0, 0, I get 0 is greater than 0 plus 3, 0 is greater than 3. Well, that's false. Okay, 0 is not greater than 3. So what I want to do now is, because it's false, I'm actually going to shade the other side of the line. Okay, so it's going to be shaded like this. Okay, now remember, all of the points in the shaded region are satisfy the inequality, but because it's a dashed line, if there's any points that are on that line, like the point 0, 3, like if I plugged in the point 0, 3, okay, 0, 3, and I plugged it in, I would get 3 is greater than 0 plus 3, okay, or 3 is greater than 3. Well, that's a false statement. So that point 0, 3 does not satisfy the inequality. Okay, looking at number 4, let's get back on pen, not highlight. Okay, number 4, we're going to divide both sides by negative 4. Now, I want you to be really careful here, because remember, when you divide an inequality by a negative, if you multiply both sides by a positive, or if you divide both sides by if you multiply both sides by a negative, or you divide both sides by a negative, you've got to remember to flip that sign. So y is going to be greater than or equal to negative 4x. Okay, so now when we graph it, our y-intercept is at 0, and our slope is at negative 4. So let's go down 4, 1, 2, 3, 4, and over 1, or up 4, and to the left 1. Okay, so because it's less than or equal to, this is actually going to be a solid line. So we make our solid line. Okay, that's not a very good one, but let's try that graph. Okay, there's our solid line. Okay, now we're going to test a point, but we can't test 0, 0 because it's right on the line. So let's pick another point. I'll do, again, 2, 2. Let's check that point 2, 2. So if I plug in 2, 2, all right, I've got 2 is greater than or equal to negative 4 times 2, or 2 is greater than or equal to negative 8. Well, that's a true statement. So because that's a true statement, that means that I'm going to shade everything on this side of the line. Okay. All right, so that's how we do our shading. So what I want you to do right now is, we're jumping back to telling whether the ordered pair is a solution. So you're just going to tell me, plug in the value x and y, and tell me if it's true or false, or yes or no if it's a solution. So try that, and then come back. You're going to do 5 through 10. Okay, so do 5 through 10 right now, and then we'll come back. I'll continue on the next video because I'm out of time.